All right, let's make this tic-tac-toe board actually do something interesting. So as I get started building a new UI, one of the things that I want to make sure I have solid first is that the state is managed, the UI is actually rendering properly, and then I can add the interactivity. So the first thing that I'm going to do is make sure that I've got my state working properly. So here we just have some default squares. It's just an array of 9 elements. And I'm going to go ahead and say squares at index 0 equals x, and squares at index 1 equals o, and squares at index 2 equals x. And that should get me an xox. Perfect. Okay. Another thing that I want to make sure, in addition to all of this, is that when we have a winner, we show the status as a winner. So I'm going to go ahead and continue this. We'll say squares at index 3 is x, and squares at index 4 is o. And then we'll just go ahead and say squares at index 6 is x. I'm pretty sure that should give us a winner board. Yep, there we go, right there. Perfect. Okay, so now I want to get the status rendering properly based on that. And so here we've got our status. That's where we need to put that status. So where do we get the status? So we can actually derive all of the state for this tic-tac-toe board based on this squares array, okay? So that's what we're going to go for, and we actually have these functions down here to help us calculate these values based on those squares. And if you want to, you can delete these and write them yourself if you want that challenge, but I thought that it wasn't super critical to your understanding of being able to derive state from other state, and so that's why we're going to be just calling into these functions. Now this calculate status requires a winner, the squares, and the next value to determine what the status should be. And we can get the winner from this calculate winner and the next value from this calculate next value. And these just determine all of that state based on the squares. So let's go get all of that derived state. So here, we'll just do multiple cursors here. We'll get our next value, our winner, and our status. And each one of these is going to be calculate. And here, let's get rid of those multiple cursors. So for this one, it's going to be calculate next value. For this one, it's going to be calculate winner. And for this one, it'll be calculate status. Okay, so for the calculate next value, we need to provide the squares to determine who the next player should be. For calculate winner, we also can provide the squares. And then for calculate status, we need to pass the winner, the squares, and the next value. And so this is kind of the interesting point here, is that we have some state that we're going to be managing. We're not managing it yet with useState, but we'll get to that. And then we have some derived state values, and then we have a state value that's derived by state and derived state. So kind of all put together to get us what this value of our status should be, which is pretty cool, interesting. So let's go ahead and grab that status now that we've got it, and put it right in here, and we should see that X is the winner. Sweet! X is winner. Oh, and I put that in the wrong spot. I knew I was going to do that. We need that status to be right here. Status. There we go. All right, so we get a winner is X. Perfect. And so because our status is based on these other pieces of derived state, we know that those ones are also working, so we've got this all wired up properly. So now it's just a matter of filling out our interactivity here. So let's get rid of all of that. And let's just double check here. We've got this select square, and that select square is going to be called in this render square. So each one of these squares is represented by this render square function, which simply renders a button with that square by its index. And then when that button is clicked, we're going to call select square with that index. And then here we take that square, and we've got to update our square's state. So let's turn this into manage state here. So this is going to be our initial value. We'll say react use state with that initial value. We'll destructure the array we get back to get squares and set squares. And now what we're going to do is I'm just going to actually get rid of all this stuff, and we'll start here from scratch. And the first thing that we want to do is in React, mutation is a problem, and you don't want to mutate the state that's being managed, in part because if you do that, then you can have some unexpected bugs, because React pretty much relies on the fact that anytime there's a state change, you're going to trigger a re-render. And if you're mutating things then you could have some stale closures that are referencing the mutated values, and it just, in general, mutation leads to some pretty hard to track down bugs. So instead of updating the squares directly, I'm going to make a copy of the squares. We'll call that squares copy, and we'll spread the squares right here to make that squares copy. So we make a new array and spread all of the values from that squares, and then we'll take that squares copy, and this we can mutate just fine because this isn't actually managed in state yet. So we're going to take that squares copy at the square index, and we'll set that to our next value. Okay, so whatever the next value was, whosever turn it was, that's the value that's going to go into the squares at that index. And then I'm going to call set squares with that squares copy. Great. So now I click here and I click here, and we're getting our state updated, our status is being updated. But one thing that you might notice is I can actually keep on going. And this is probably not the type of game that you'd want where O can just totally dominate. We don't want to have that kind of a game. So the reason that's happening is because we don't prevent the game from continuing after the game is over, and we also don't prevent users from changing the value of a particular square. So let's go ahead and say if there's a winner, then we'll return. And also, if there's a value in the squares at that particular index, then we'll have that return as well. And with that now, we can click, and then if O decides, you know what, I want to be right there, they can't just click on an existing square. That's not going to work for them. So we've enforced the rules of the game this way. All right, the last thing here that we want to add is the restart functionality. So basically, we just need to restart to our initial state value. And so all we've got to do is call set squares, and we can set it to a new array where all of the items in the array are null. So we can get started, and if O gets here and they're like, oh man, they blocked me, and they say, I want to restart. Boom, restart, we start all over, and we can get going on the next game. Now there's another thing you might consider doing in this kind of a scenario where you could say initial squares, and then say initial squares, and then on your restart you could just pass in initial squares. That way, if you ever decide to change the way that your state's being initialized, that restart will get initialized with the exact same thing. But I mostly wanted to show you that as an idea. I think I'm going to leave it the way it was. It was fine. So in review, what we did here was we turned the squares into managed state, and then we derived other values of state based on that square's state and even other derived values of state. And then we were able to use those values in other areas of our code for this event handler and for what we render out into our UI. We implemented our click handler for the squares. We made sure that if there's already a winner or if there's already a value at that index, we just do an early exit. User can't do anything with that. And then we made a copy of the squares, so we're not mutating the state that's actually managed within React. And then we mutated that copy to set the value. And then we put that copy into the squares state, triggering a re-render of our board so that our squares value is now what the squares copy was. And then we also implemented the restart by setting the squares to a new array of 9 elements that are all null.